Welcome to Chapter 1, Proposition and Predicate Logic. In this section, we will explore the functions of logical reasoning, which form the basis of mathematics, computer science, and the many fields that require systematic thinking. Logical provide the rules and the principles used to evaluate statements, construct valid arguments, and determine whether the conclusions follow from the given informations. Understanding the logic is essential for the developing mathematical proof, solving problems effectively, and communicating ideas with precision. We begin by examining the concept of proposition. A proposition is a declarative statement that has a defined truth value, meaning it is either true or false, but not both. Therefore, a proposition is a declarative sentence which have truth value either true or false, but not both. A statement is such as 2 is a prime number and 6 is an odd number are a proposition because the truth values can be determined. However, questions, commands, and expressions without a definite truth value are not considered as propositions. Next, we will study logical connectives, which are the tools used to combine simple propositions into more complex and meaningful logical statements. Instead of working with isolated statements, logical connectives allow us to link ideas and express relationships between different propositions in a structured way. The fundamental logical connectives including conjunction, disjunctions, negation, implications, and by condition, or what you call by implications, are the 5 basic logical connectives. Conjunction is represented by and. The symbol is as displayed on the digitals. You can see it combines 2 propositions and produce a true statement only when both propositions are true. If even one is false, the entire statement will become false. Disjunction is represented by or. It connects 2 propositions and result in true statement if at least one of the proposition is true. That means the proposition connected by using the or logical connective is false if and only if both propositions are false. It is only become false when both propositions are false at the same time. Negation is represented by not. It is a single operations connective that reverts the truth value of the original proposition. If the original proposition is true, its negation becomes false and vice versa. Implication is represented by if then. It describes conditional relationship between 2 propositions. It is false only in the case where the first proposition is true and the second is false. In all other cases, it is considered true. This connective is widely used to express logical reasoning and cause and effect relationships. By conditional, or the so-called by implication, is represented by if and only if. It shows that the 2 propositions are logically equivalent. A biconditional, or what you call by implication statement, is true when both propositions share the same truth value, meaning both are true or false. The chapter also introduced truth table, which provide a systematic method for determining the truth value of compound propositions under all possible conditions. The truth table helps us understand the behavior of the logical connectives and serve as an important tools for evaluating logical expressions and arguments. Another important topic is the classifications of the logical statements. Some compound propositions are always true regardless of the truth value of their components. These are known as tautologies. Others are always false and are called contradictions. Identifying the tautology and contradiction helps us analyze the structures and validity of the logical reasoning. We will also examine the concept of logical arguments, and actually that argument consists of one or more premises and a conclusion derived from those premises. An argument is considered valid when the conclusions must be true whenever the premises are true. For example, if we know that if it is rain, the ground will be wet, and it is rain, then we can validly conclude that the ground is wet, because if it is rain, the ground will be wet, and it is rain are a premises, and the conclusion for it is rain is the ground will be wet. Understanding the valid and invalid argument is a fundamental skill in mathematics and the logical reasoning. For example, consider the statement, if it rains, the ground is wet. If we also know that it is raining, the conclusion that the ground is wet, logically it is followed, because the rain is raining, then the ground will be wet. However, if we only know that the ground is wet, we cannot automatically conclude that it is rain, because other factors such as a sprinkler may have caused the ground to become wet. By the end of this session, you will be able to define propositions, identify and use logical connectives, construct and interpret truth table, distinguishing between the tautologies and the contradictions, and evaluating the validity of logical argument. See you in the next session.